And a very good day. We are from Group 2B, Section 2, Mechanics Engineering Lab. So my name is Muhammad Arif and my fellow group member IZZAT, ANIQ and ARIF and AZIM. So today we'll explain about buckling of strut experiment. As you can see here, this is our experiment photo. We are doing the procedure of buckling strut experiment. We follow all the instructions and safety procedure that have to be done when we conduct our experiment. So we also have to also note some of the issue when we done the experiment, such as we have a problem with the screw that we need to be tight at the strut. But however, with the help of laboratory assistant, we have managed to do it.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad bin JUMALI, entry number DD200096. I'm from group 2B from section 2, and today I will be presenting about the theory of topic 2, buckling of strut. Okay, for the theory, buckling is when a structural component suddenly deforms under load, and different shaped struts buckle in a different ways. So, when a long thin column have loads acting on them, axial load, they will bend like this. Like in the figure on the left, and when a short thick column when they have loads acting on them, they will potentially crack and fail. Okay, so the study in this lab, we study about the buckling of slender columns and relationship between the length and fixing conditions and buckling load. So in this lab, multiple struts were used, but they have multiple length, and the end fixing condition are pin to pin and fixed end to fixed end, and the pin end to the fixed end. So according to the Euler's theory, the strut is initially straight, axial load is applied, and the strut is made of homogeneous material. So this is the Euler's theory of derivation of equation.
Assalamualaikum, my name is Muhammad FARIS bin MUSTAMAM. My metric number is CD 200 and 213. Now I will explain about the experiment procedure. First of all, there are three conditions that the struts undergoes during the experiment. First condition is a pin end, the second condition is the pin fix, and the third condition is the fix. For pin end, the strut is placed at the V notch and just tighten the screw at the bottom. And for the pin fix, the strut were placed at the V notch, and the strut were tightened by using the cap head screw. And for the last condition, which is the fix, the strut is placed at the V notch, and the strut is tightened by the cap head screw at the top and the bottom. So now are the procedures for the strut experiment. First of all, fit the shortest struts to the machine, and then measure the cross section of the struts and calculate the second moment of error, which is I. I is equal to BD cube over 12. And second step is adjust the position of sliding crosshead to accept strut using thumb nut to lock the slider. And the third one is to tighten the locking screw. Fourth one is make sure the strut is resting on the notch before transmit any load. Next is set the reading to 0 by turning the force output knob, and then start to load the strut. If the strut buckle to the left, flip the strut opposite of the direction, and vice versa to reduce error. And second last is record the buckling load, which is when the number is not increasing or decreasing, which is the number is remain the same. And lastly, repeat with the other strut, which is strut 2, strut 3, strut 4 and strut 5, and change the support direction.
Assalamualaikum, my name is Muhammad Azim bin Abdul Aziz. My matrix number is AD1900 and 66. I will present the data obtained and the graph plotted from the experiment. From the result for experiment 1, which is pin N, the experimental buckling load is slightly higher than theory buckling load. And for the result from pin fix experiment, the theory buckling load is slightly higher than experimental buckling load. And finally, for the experiment 3, which is fix N, the theory buckling load is slightly higher than experimental buckling load. From the graph pin N, the gradient of experimental gradient is higher than theoretical gradient. Thus, the experimental ratio is lower than the theoretical ratio. From the graph pin fix, the gradient of experimental is higher than theoretical gradient, and the experimental ratio is lower than the theoretical ratio. And for the last graph, which is fix N, the gradient of theoretical is higher than experimental gradient. Thus, the theoretical ratio is lower than the experimental ratio. And from the experiment 1, the pin N have the lowest buckling load, as the length of strut used in experiment 1 was longer, while the experiment 3, fix N, have the highest buckling data because of the length of strut used is shorter.
Assalamualaikum and good day. My name is Muhammad IZZAT bin OSMAN, number matrix CD200-201, and now I'm going to talk about calculation for our lab, which is lab topic 2, buckling of strut. Firstly, for the formula used in buckling of strut for pin N, strut is PE is equal to pi square times EL over L square. For the pin fixed strut is PE equals to 2 pi square times EL over L square, and for the fixed N strut is PE is equal to 4 pi square times EL over L square, while PE is for Euler buckling load, E is for the Young modulus, I is for the second moment of area, and L is for the length of the strut. Next is the calculation for pin and strut. The length is equal to 0.32 meter, the EE is equal to 69 gigapascal, BE is equal to 0.019 meter, and D is equal to 0.02 meter. To find the second moment of area, then substitute the information to the formula for pin and strut to find the load, and we get 84.26 Newton. As for the L over L square, we get 9.77 meter negative 2. This calculation continue until strut number 5. Then the calculation for pin fixed strut, the length is equal to 0.3 meter. The second moment of area is equal to 1.267 times 10 to the power of negative 11 meter 4, and the Young modulus is equal to 69 gigapascal. Then substitute to the formula, and we get 191.74 Newton for the load, and 11.11 meter negative 2 for the L for the 1 over L square. This calculation continue until strut number 5. And the last calculation for fixed and strut, the length is equal to 0.28 meter. The second moment of area and the Young modulus are the same as the previous calculation. Then substitute to the formula for fixed and strut, and we get 440.22 Newton for the load, and 12.76 meter negative 2 This calculation continue until strut number 5.
Assalamualaikum and good day. My name is Muhammad Arif bin Muhammad Ali. Matric card number CD 2082. So today I'll explain about a buckling incident. So buckling is a creasing failure by crumpling of a longitudinal structural member loaded centrally with a compressive force. It occurs to long and slender members subject to axial compressive stress. Buckling load is a compressive load at which a column or strut begins to buckle. As you can see, the photo on the right side, there's the two photos. The first one is the buckling of buckling steel column. So it happened in a small construction site, but it's also happened, as you can see, the next photo is a flyover beams has been buckled because of the compressive stress that it has been received. So next, as you can see, when the cross-sectional area is small as compared to the height, so it's failed due to the buckling because the structure cannot support it, so it will begin to buckle. As you can see, the two photo on the right side, the two photo is a highway supporting beam. It has been buckled because of the compressive it has been received. And next, as you can see, this is the 21-story building in India. It collapsed due to the buckling failure. So it occur when the load buckling structural failure occur when the load reach a certain critical value known as critical load. Buckling takes place abruptly. Buckling also and in under load members because it's unstable, but it will generally not fracture. Instability caused by the buckling in one member can lead to excessive stresses in other member, causing progressive collapse of the whole structure. Buckling is usually is due to the axial stress applied along the longitudinal axis of the member to the beam or the structure, to the supporting beam or the main base structure of a building. So when the main base is it begins to buckle, so it's very dangerous and as you can see here, the photo, it can happen. The collapse of the building can happen. I think that's all from me, and thank you.